The James Webb Space Telescope, JWST, stands as a premier observatory in modern space science. Its core mission is to uncover the secrets of our own solar system, investigate distant exoplanets orbiting stars far beyond, and examine the complex structures that define our universe and our place within it. In a groundbreaking development, scientists recently directed the JWST toward a star located 120 light-years away from Earth. This powerful telescope detected compelling evidence of carbon-based molecules in the atmosphere of a potential ocean world, an extraordinary discovery that has left the astronomical community in awe. But how is such a discovery even possible? This finding offers an unprecedented glimpse at a planet strikingly different from any within our solar system and raises profound questions about the potential for habitable worlds across the cosmos. Join us as we explore this fascinating breakthrough and the intriguing details it unveils. If you're passionate about space exploration and want to stay updated on the latest cosmic discoveries, be sure to like this video, share it, subscribe to our channel, and hit the notification bell so you never miss an update. NASA's James Webb Space Telescope has made a significant leap in exoplanet research by studying K2-18b, a planet approximately 8.6 times more massive than Earth. What makes this discovery remarkable is the detection of carbon-containing compounds, specifically methane and carbon dioxide, in its atmosphere. These findings build on earlier research and bolster the idea that K2-18b may have life-supporting conditions. The planet appears to have a hydrogen-rich atmosphere and a surface potentially covered by oceans. Initial atmospheric analysis was carried out using NASA's Hubble Space Telescope, which offered valuable insights into this intriguing system. K2-18b is situated 120 light-years away in the constellation Leo and orbits a cool dwarf star known as K2-18. Importantly, it resides within the habitable zone of its star, where temperatures might allow for the presence of liquid water. Planets like K2-18b, falling between Earth and Neptune in size, are rare in our own solar system, making them particularly fascinating to astronomers. The presence of carbon compounds and a hydrogen-dominated atmosphere makes this exoplanet a prime candidate in the search for signs of life. The detection of methane and carbon dioxide, combined with the absence of ammonia, further strengthens the theory that K2-18b may host a liquid ocean beneath its thick atmosphere. There's also preliminary evidence suggesting the presence of dimethyl sulfide DMS, a molecule typically produced by marine plankton on Earth. However, this signal is still tentative and requires further confirmation. Additional observations using JWST and other instruments are expected to shed more light on whether DMS exists in significant quantities in K2-18b's atmosphere. A researcher from the University of Cambridge emphasized that while the planet is in a habitable zone and contains carbon compounds, it doesn't necessarily mean life is present. With a radius 2.6 times that of Earth, K2-18b may possess a dense, high-pressure icy mantle, much like Neptune, surrounded by a thinner, hydrogen-rich atmosphere and an ocean-covered surface. Although liquid oceans are expected, there remains uncertainty about whether they can support life as we know it. Nevertheless, scientists have successfully captured the most detailed atmospheric spectrum of any habitable zone sub-Neptune planet to date, revealing critical molecular signatures. A Cardiff University researcher noted that this was achieved by analyzing starlight passing to the planet's atmosphere as K2-18b transited its host star, making it a transiting exoplanet. The brightness of the star dims when the exoplanet passes in front of it. This is how NASA's K2 mission initially discovered the planet. During these transits, some starlight filters through the exoplanet's atmosphere before reaching telescopes like the James Webb Space Telescope, JWST. As the light travels through the atmosphere, it picks up unique spectral signatures that allow astronomers to identify the gases present. To build on these findings, the research team plans to use JWST's mid-infrared instrument, MIRI, for further analysis. Their ultimate aim is to explore the climate of K2-18b in more detail and search for potential signs of life, a discovery that could fundamentally transform our understanding of life beyond Earth. But this isn't the only groundbreaking insight from JWST. Astronomers using the telescope have also detected complex organic molecules, similar to smog or smoke, in a distant galaxy. This marks the earliest known detection of such molecules in the universe. Personally, I find this both awe-inspiring and deeply thought-provoking. These findings challenge the limits of our current cosmological models and expand our sense of what is possible. What makes this discovery especially significant is that these carbon-rich compounds, called aromatic hydrocarbons, were found in a galaxy that existed when the universe was just 10% of its current age. These molecules, which are also found in fossil fuels and industrial pollution on Earth, are large and complex, made up of dozens or even hundreds of atoms. The fact that such intricate molecules formed so soon after the Big Bang defies long-standing assumptions about the timeline of chemical complexity in the cosmos. To put this into perspective, the light from this ancient galaxy began its journey less than 1.5 billion years after the Big Bang. Given that the universe is now about 13.8 billion years old, we are observing one of the earliest known stages of cosmic evolution. What's truly remarkable is that JWST made this detection possible, and it will continue to unveil similar secrets for perhaps another billion years. It raises a fascinating question. If we could peer even further back in time, might we find even more of these molecules, perhaps formed even closer to the origin of the universe? Previously, scientists could only confirm the presence of such molecules in ancient galaxies. Now, thanks to JWST's unmatched resolution, we can precisely map where these molecules reside. Interestingly, in the case of Galaxy SP 4-1847, the molecules appear to be unevenly distributed, something that still puzzles researchers. Even more astonishing is the fact that this early galaxy was already as massive as the Milky Way and its stars rich in carbon and oxygen, despite being only a tenth the age of our own galaxy. As humanity continues to explore the cosmos, armed with revolutionary tools like JWST, we are constantly reminded of the universe's vastness and complexity. Each new discovery brings us closer to answering profound questions about our origins and our place in the grand cosmic story. If you enjoyed this video, don't forget to like, subscribe, and turn on the notification bell. And let us know your thoughts in the comments. What do you think we'll discover next? The James Webb Space Telescope is already reshaping our understanding of exoplanets, galaxies, and the early universe. Its ability to detect complex organic molecules in the most distant corners of space highlights just how close we might be to uncovering the building blocks of life in places once deemed impossible. This is only the beginning of a new era in space exploration. The detection of compounds in atmospheres of exoplanets like K2-18b is opening new pathways for exploring potential biosignatures on worlds that may share similarities with Earth. Molecules such as methane and carbon dioxide, often linked to biological activity on our planet, have now been identified in the atmospheres of these distant worlds. While their presence doesn't confirm life, it raises important questions and invites deeper investigations into whether the conditions for life could exist elsewhere in the universe. The James Webb Space Telescope, JWST, marks a significant leap forward in our ability to study these planetary atmospheres with unprecedented precision. It can detect not only basic elements, but also complex organic molecules that might indicate the presence of biological processes. This level of detail is essential for assessing the habitability of exoplanets and searching for subtle signs of life, whether in the form of atmospheric gases, organic compounds, or other telltale markers. Beyond its exoplanet research, JWST is transforming our understanding of galaxy formation and evolution. By observing ancient galaxies, scientists are able to trace the history of star formation, the distribution of elements, and the mechanisms that drive galactic growth. Such insights are crucial for unraveling the story of our own Milky Way and its development over cosmic time. One remarkable example is the discovery of aromatic hydrocarbons in galaxies that formed relatively shortly after the Big Bang, suggesting that the basic building blocks of life appear far earlier than once believed. These findings deepen our understanding of the early universe and highlight how much there is still to learn. With each new observation, JWST brings us closer to answering profound questions. Are we alone in the universe? What conditions are necessary for life to emerge and thrive? How did the universe begin, and what is its ultimate fate? The James Webb Space Telescope is not just a scientific instrument. It's a beacon of human curiosity and exploration. Its groundbreaking capabilities allow it to probe the cosmos in ways never before possible, offering a window into the formation of stars, planets, and galaxies with stunning clarity. As JWST continues its mission, we can expect a wave of revolutionary discoveries that challenge and refine our understanding of the universe. From identifying new planets and studying their atmospheres to exploring ancient galaxies and the potential origins of life, the telescope is at the forefront of space exploration. In the years to come, JWST will play a central role in reshaping astronomy and deepening humanity's understanding of its place in the cosmos. Its mission of discovery is one that will inspire generations and help unlock the secrets of the universe, revealing wonders we've only just begun to imagine.